Hello guys. So as you know, ICSE 2023 examination is coming very near to us, and we are definitely very much tensed in the wake of various mock examinations held in different schools, and after that you have to appear for the D-Day. And here we are going to discuss about all the types of numericals for work, power and energy chapter of ICSE physics and how to solve them, most probable numericals, all the previous year's questions, everything will be covered in this video. So let us start our discussion on it. We will start with various important formulas that are required for this chapter. So first of all we will discuss only the formulae. So our chapter is work, power, energy. So everybody with copy and pen, let's start and finish this chapter 2, all numericals, in this revision express series of physics ICSE 2023. So W, the first one, work. Work formula is force into displacement cos theta. This theta is the angle between the force and the displacement vector. Next is power. Power is basically work by time. So that is force into displacement by time, that is force into velocity. Next we have to do other formulas too. Formulas like potential energy is mgh, kinetic energy it is half of mass into velocity square. Next there is a very important theorem that is called work energy theorem. This is very important. So in work energy theorem, what we understand is work done is equal to change in kinetic energy. So this is also a very important formula and used in various problems. Next we know momentum is equal to mass into velocity, and this momentum is related to kinetic energy by the formula P is equal to root over 2m into kinetic energy. So we are not deriving any formula over here, rather what we are doing is we are recapitulating the formula, because at this point of time you need to recapitulate the formulas, you need to derive, definitely you need to derive, but here in this video we will focus on how to solve the numericals of work, power, energy. So these are the basic formulas that will be required in solving various problems of work, power, energy. So please note this, all these formulas down, so that we can go ahead and solve problems together. You and me, everybody together, we are going to solve these problems. Okay, so please copy this. So this is our first problem that we are going to do. So what is given over here? A boy weighing 40 kg climbs up a stair of 30 steps, each having 20 centimeter height, in 4 minutes. The girl does the same, but the girl having a weight of 30 kg only, but does the same in 3 minutes. The girl is efficient, I guess. Compare work done and the power, and the value of G is given. This question was asked in ICSE examination 2016. So let us go ahead and try this problem out. So please copy the question, pause the video, copy the question, and then let us do together. So here it is said about one boy and one girl. So what I'll do is I'll write the boy on the left hand side and the girl on the right hand side. So this will help me in comparison. So see, the mass of the boy is given as 40 kg and the mass of the girl is given as 30 kg. So here I can easily calculate the weight of the boy and the girl. So the weight over here is 40 into 10, that is 400 Newton, and here the weight is 30 into 10, because the g is given, weight is equal to mass into acceleration due to gravity. 30 into 10 means 300 Newton. Now what is the height they are going in the stairs? So each step is 20 centimeter, so the displacement over here is 20 centimeter. I will convert it into meter, 20 by 100 meter into 30 steps. So it will come out to be 6 meters. So this is same for both of them, right? This is same for both of them. This is not going to change. Now you have to calculate the work done. So here I have written as W only. So you can write this as WT. So it will be easy to differentiate. Now what is work done? Work done is basically force into displacement. So here 400 into 6, so 2400 joule, and here work done is 6 into 300, 1800 joule. So this is the work done of the boy and this is the work done of the girl. So if you want to compare means basically you have to calculate the ratio. So W boy by W girl will come out to be 2400 divided by 1800. So this will be 4:3. So this is the ratio of the work done by the boy and the girl. Okay, so the girl has done lesser work. Now they also said to calculate the power and find out their ratio. So you have to also calculate the power over here. I'll go to the next page. So again I'll write boy and girl. So power is what? Power is work done by time. So here work done is 2400 joule, time is 4 minutes, so I'll write it 4 into 60 second, and here the power will be same, work by time, but here it is 1800 joule divided by 3 into 60 second. So I can multiply and divide all those things, but you can directly find the ratio because both of these has 60, so I am not going to use it. This will be 600 and this will be also 600. Okay, quite good. I think we can easily cancel it out. So this is come out to be 60 watt and this is also coming out to be 60 watt, correct? So not 60, 10 watt, 10 watt, because 60 divided by 6 is 10. So power of the boy is to power of the girl is 1:1. So the boy had much weight than the girl, so work done by the boy was more, but however if you compare the times also, then the power is coming into the effect, and in case of power we can see the power applied or the power developed by both this boy and girl is same. Okay, so this was a nice problem asked in 2016 ICSE examination. We'll go to the next problem now. Now our next problem, this problem was given in ICSE specimen paper 2014. So here it is said, find the change in kinetic energy if the velocity is reduced to 1/3 of the original velocity. So how will I do this problem? So kinetic energy formula we know very well. Kinetic energy formula is half into mv square. So here there are two cases basically, right? So one is case 1, another is case 2. So in case 1 the mass is m1. In the second case the mass is also m, correct, because the mass hasn't changed. Velocity in case 1 I am taking as v, velocity in case 2 has been reduced to 1/3 of the original, that means it has become 1/3 of the original, that is v by 3. So, the kinetic energy over here is K1 is equal to half mv square, and here the kinetic energy is K2. So, here you just put a differentiation mark. Here it is half m v by 3 whole square. So, here it will come out to be half m into v square by 9. Next, it is said what is the change in kinetic energy. So, what I will do is I will write K2 by K1. So, if I write K2 is half m v square by 9 and K1 is half m v square. So, this v square and this v square cancels out, m cancels out, half cancels out, only thing that is remaining is 19. So, here I can say K2 is equal to 1 by 9 K1. So, here kinetic energy is reduced to 1/9 times. A very nice problem, simple application of kinetic energy formula. So, we can move to the next problem. So, you will all have to do with me, because otherwise you are not going to gain confidence. You have to do the problems with me. It is just a matter of practice which you may not have done earlier, but even if you do now, you are going to reach the same height as your friends will reach. Okay. So, let us go forward. So, this is our next problem, ICSE 2013, another concept, another new problem, but a very easy problem. So, step by step what we will do, we are going to understand what the problem has said. It has been said that a force has been applied on a 20 kg body. So, there is a body that is this one 20 kg, and so this is the mass of the body, and the body is moving with a velocity of 40 meter per second. So, initial velocity of the body is 40 meter per second. Okay. Now, you put a force on it. They have said that you are putting a force on it. Okay. That force is put for 2 seconds and the body velocity has changed. So, here the final velocity of the body is 50 meter per second, okay, in 2 seconds. So, what is the work done? That is what we have to calculate. So, as the velocity has increased, definitely the kinetic energy have increased. And what is the formula we have studied, or we know rather, which relates work done with kinetic energy? Let us go a little bit backward. Can you look for this? Work energy theorem. Work done is equal to final kinetic energy minus initial kinetic energy. So, that is it. We have to apply over here. So, work done is equal to final kinetic energy half m v square minus initial kinetic energy. Understood? I can easily take that common, right? Here, from the here I can easily take half m common. So, it will be v square minus u square. So, that is what I am using. So, I know all the values, half into 20 kg, v square is 50 square minus 40 square. Every value is known to me, 10. Everything is in SI unit. So, work done will come in joule. 50 square is 2500 and 40 square is 1600. So, you need to calculate this. This is a very easy calculation. 2500 minus 40 square is 1600. So, 900, here it will come 900 into 10. So, 9000 joule will be the answer. So, this is a very simple application of work energy theorem. So, next problem. So, one by one we are solving problems, we are hovering around various concepts and various problems are getting solved by the only formulas that we have listed in the first board, right. This is our next problem, another different kind of problem asked in ICSE 2010, and here is a spring holding a trolley of 0.5 kg and it is kept in compressed state. when this trolley is released, or the spring is rather released, the trolley moves in 2 meter per second. It moves with 2 meter per second. We have to find out the possessed potential energy originally there in the spring. So when the spring was compressed, it had stored potential energy. As soon as it is released, it gets converted to the kinetic energy. So what we will take is over here that all the potential energy that is possessed by the spring is converted to the kinetic energy of the trolley. Kinetic energy of trolley, PE possessed by spring. So Ke of the trolley can be easily found out. This is not a very difficult case. Ke of the trolley can be easily found out. How? Half into mass 0.5. At the end of the day, it travelled with a velocity of 2 meter per second. So it will come out to be 0.5 into 2 into 2, 1 2 gets cancelled out. 0.5 into 2, that is 1 joule, because everything was in SI units. Okay. So very important question, nice question, one of a kind, different questions. You may have seen this question in your textbook, but remember one thing, if this question was not in your textbook and asked the first time in the examination, then it wouldn't have been a very easy question for you. Okay. So give thought to every question, how it is done and what is the concept behind it, rather than okay, I can do this problem. The concept behind it is potential energy gets converted to kinetic energy, because the summation of potential and kinetic energy remains same. That is the concept. That concept was nothing new in 2010 also. Today you may think that this 2010 problem is there in my textbook, so it is an easy problem. What's new in it? Nothing new. It was new in 2010, but the concept was old. PE is equal to KE. So look for the concept rather than the problem, I would say. So don't look for that this numerical I can do, that numerical I can do. While you do the numerical, look for the concept behind the numerical, because with that concept another question is going to be asked in your examination. So concentrate on the concept. Understood? Next problem. So coming to our next problem, another problem from previous year ICSE paper. A body weighing 400 Newton possesses 500 kilojoules of kinetic energy. Okay. So if the weight is 400 Newton, so in this question it was mentioned that G is equal to 10 meter per second square. Okay. So mass of this body will be then 400 Newton divided by G, that is 10 meter per second square. So the answer will be 40 kg. So I also got the mass of the body. Now it has been said that it possesses 500 joule of kinetic energy. Find Ke. I think there has been a little mistake over here. It should be find the velocity. Find velocity. Okay. So see, Ke formula is half into mv square, right? So kinetic energy value is given over here, 500 joule, half into 40 into v square. 10 cancels out, 2. So v square is equal to, this 2 will be cutting down 50 into 2 parts, 25. So v will be 5 meter per second. Very easy question. So this type of questions, just sometimes what happens while we are attempting the paper, this type of question also we miss. How do we miss this type of question? We miss this type of question due to the reason that we don't generally give time to the question, we don't write down what is given in the question, and we don't ponder over the formulas. So these are direct formula based questions. So just if you can apply the formula, you can get the answer, straight cut. So that's what you expect at boards level. So that is it. So please practice this kind of questions, and this kind of questions should not be missed. It's a God's gift. Okay, next, calculate kinetic energy of a body. Okay, in this case it is said you have to calculate the kinetic energy of the body. So kinetic energy formula I'll write down, because anyway I will be using this, right? Mass is given as 0.11 kg and momentum is also given, P is equal to 20 kg meter per second, 20 kg meter per second. So how am I going to do it? I can easily find out the velocity over here, because mass into velocity is equal to 20 kg meter per second, and mass is given, so velocity will be 20 divided by 0.11 kg meter per second. Okay, so if you want to calculate this will be a little lengthy. I'll take this as 0.1, so it will be approximately 200 meter per second, approximately 200 meter per second. 0.11 it is given, that's why. So if you now put these values over here, half into 200 square into mass is 0.11, so this will come out to be 200 into 100, 200 into 100 into 0.11. 0.11 into 100 will be 200 into 11, so this will be 2200 moment. What it is said to calculate the kinetic energy, so it will be joule, 2200 joule. Okay, so here I have taken some approximation. You need not do that, you need to divide and find out what is this one. Okay, but I really have doubts that they are going to give you this kind of 0.11 kg. Maybe they will give you 0.1 kg. Okay, otherwise you have to divide and find out. Okay, so this is a very easy question again. So we'll proceed to the next one now. So see, after doing these 6 problems, we are already gaining in confidence. We can do easily only application of formula. But in this problem number 6, I would like to say you could have used this formula also. Momentum is equal to root over 2m into kinetic energy, because this formula we have done in our formula sheet here. See, this formula also you can use directly. So here also you could have calculated easily. So here what you need to do, K is equal to P square by 2m. So from here you can easily get this one, and you can substitute the values and find out the answer. So in that case you need not calculate velocity separately. From mass and momentum itself you can easily get the value of kinetic energy. So this is our next problem. Okay, it is a problem on simple pendulum, so it should be very simple, right? So a simple pendulum is there, wherein we will always have a bob. Okay, we have a bob. Here you are imparting a velocity of 5 meter per second. So this is the mean position. So at mean position what happens, the velocity is maximum, right? So the kinetic energy is maximum at mean position. So kinetic energy over here will be half into mv square into m into v square, that is 5 square. So this is the kinetic energy at this point, and at this point potential energy will be considered as 0, right? Now this is important. The question is what maximum height it is going to reach. Okay, so it is going to, maybe we are taking this point, this is the height it is going to reach with respect to this one. So this is the height it is going to reach. At maximum height what happens is velocity becomes 0. Why velocity becomes 0? Because all the kinetic energy that we have imparted in the mean position is converted to potential energy. So potential energy is equal to m into g is given, c 10 into h is not known. So this potential energy is derived from what? From the kinetic energy itself. So by conservation of mechanical energy, we can say this potential energy is equal to the calculated kinetic energy. So here you can easily cancel out this mass. So this 10, so 20h is equal to, here 5 square is 25. So h will be 25 by 20. So 5 by 4. So this will be 1.25 meter. Okay, 1.25 meter is the maximum height that can be reached. Coming to the next. So this type of questions are also very important. So please, while doing these problems, you do draw the diagrams, because many a times what we do, we don't draw the diagrams. But remember, when we start this numericals in physics, normally the numericals in physics starts from class 9th. One basic teaching given to all the students by all the physics teachers, everyone says this: please draw the diagram, so you will be able to visualize the problem better. Okay. Okay, next question on power of motor. So power of motor is given as 100 kilowatt. Power is given as 100 kilowatt. So 100 kilowatt means in SI unit 100 into 10 to the power 3 watt. Very good. ICSE 2017 question. At what speed it can raise a load of 50,000 Newton? Okay, so speed and force. Okay, let us go into our formula sheet. See, we have already discussed this. Power is equal to force into velocity or speed, right? So what will do? Power is equal to force is known to me, right? 50,000 Newton. Force into speed is equal to 100 into 10 to the power 3. So here see, force is known to us 50,000. So 50 into 10 to the power 3 into velocity is equal to 100 into 10 to the power 3. 10 to the power 3, 10 to the power 3 cancels out. This 50 will cancel out this 100 by 2. So velocity will be 2 meter per second. Okay. So another nice question getting solved in a very easy fashion. But as you can see, these are direct questions. Normally ICSE asks direct questions in physics. Numericals are asked directly from the formulas. So you have to keep in mind the formulas and you have to apply in the right time. That you have to do. Okay. So this is our next problem. Work done by heart is 1 joule per beat. Okay. So per beat 1 joule will be the work done. Calculate the power of the heart if it beats 72 times in a minute. So when you calculate power, power is work done per unit time, right? So first of all, I have to calculate what is the total work done. So the work done is 1 joule per beat and number of beats per minute is 72. So total work done is 72 joule. And what is the total time? Not 1, right? 60, because it has to be in SI unit. So this will come out to be 12 by 10, that is 1.2 watt. Just a one line question, looks tough, but just a one line question if I apply the formulas correctly. Okay, so let's proceed to the next one. So our next problem now, mass of 20 kg moving with velocity 5 meter per second. That is, mass is called as P. It is written in bracket P. And there is another mass of Q, that is 5 kg moving with 20 meter per second. You have to calculate the ratio of momentum. This is again a very straightforward question. So what you have to do? Just formula based, nothing else. Momentum of P by momentum of Q is equal to mass of P, that is 20, into velocity of P, that is 5. All are in SI unit, so no problems. Mass of Q is 5, mass of velocity of Q is 20. So everything gets cancels out. right? Everything gets cancelled out and the ratio is 1:1. So simple. Number 1 was so simple. Number 2, it is said to calculate the kinetic energy of P in SI units. So kinetic energy of P will be again very easy to calculate. Half into mass is 20 kg into 5 square. So 10, 5 square means 25 into 10, so 250. Everything was in SI units, so it will be 250 joule. Plain and simple problem, direct use of formula, right? Nothing more, nothing less. Our next problem, an engine can pump 30,000 liters of water to a vertical height of 45 meter in 10 minutes. Calculate the work and the power developed by the engine. Value of G is given. So we have to calculate work first and then we'll think about the power. So again I think it will be formula based. So work done will be, the work done formula is force into displacement. We know that. Okay. So here we are moving up 30,000 liter of water. So mass of water is basically 30 kl. If you take it, it's 30 kl, kiloliter. 30,000 liter means 30 kiloliter, and 30 kiloliter means basically, so I'll write first volume, it will be better. 30 kiloliter is nothing but 30 meter cube. Kiloliter and meter cube is same. Okay, this will give you an easy way out. And so here on you can calculate mass 30 meter cube into what is the density of water, 1000 kg per meter cube. That means it will be 30 into 10 to the power 3 kg mass. So as you know the mass now, you can easily calculate the force because you know the value of G is 10. Okay, so this much is very easy. Next is, what is the height? Height will be the displacement, na? Height is 45 meters. So I'll write here 45 meter. So work done will come in joule. So what I'll do is, I'll do 3 into 45. I'll put this 0 into this one. So it will come out to be 10 to the power 5. Can you understand how did I do it? This is 10 to the power 3. There is another 10, 10 to the power 4. And in this 30 means what? 3 into 10. So another 10, 10 to the power 5. This will be 135 into 10 to the power 5 and the unit is joule. Easy question. Next is, you have to calculate the power. So power is nothing but work by time. So work is 135 into 10 to the power 5 in SI unit. Time is 10 minutes. So you have to convert into SI unit, 600. So here on you can divide it by 3. So if you divide it by 3 you will get 200, and if you divide it by 3 you will get 45. So 45 by 2 is 22.5, and 2 zeros can help in cutting down 10 to the power 5 to 10 to the power 3. So this will be 22.5 into 10 to the power 3 watt, because everything was in SI unit. Okay, so that's the end of problem number 11. It's a little bit lengthy problem, little bit calculative, but again if you see, it is direct formula based problem, correct? So by this we basically complete the all sorts of problem that can be asked in ICSE examination. We have covered a lot of PYQs. We have tried to avoid. So you may ask that whether these 11 problems are enough. See, practice is important. All the concepts has been touched by these 11 problems, and many problems like this are being repeated only by the change of numerical values. So what we did is, we did not repeat the problems. We did not repeat the problems. We took each problem of single type, so that we, in a concise fashion, in one shot, you can finish all the problems by practicing with us about work, power and energy. So this is how you solve problems in work, power and energy. I hope each and every one of you did the problems with me and will do very good in the examination, because I am pretty sure if you have done the problems with me, then definitely you have gained lot in confidence. So just a matter of some minutes that you need to put in, and definitely anything else you will gain the confidence, right? Thank you guys.